Okay. So whatever syllabus you are observing from the for the chapter number 5, kinematics of the particle, that black colored syllabus, it was there only last time. I am saying it was not there, but this time total syllabus will be there for you. So there is no question of color, black, white, whatever. So all the syllabus you will have, all the syllabus. So at the beginning of the subject, I told this our mechanics subject is classified into two parts. Which are they? Are you knowing someone?
Statistics and dynamics.
What?
Statics and
Statics and
dynamics.
dynamics.
Statics or static? Who is telling here? Okay, statics and dynamics. You know better. Very good. So chapter number 1, 2, 3, 4 we studied under statics. Now we are going to study dynamics. Okay, what is static and what is dynamic?
Static means body which is at rest.
Okay, body is at rest. And what we are studying under that then?
Forces and their effect acting on body.
Okay, forces and their effect. Very good. And dynamics?
That deals with forces.
Okay, again only forces. Is it the case?
And
dynamics?
body in motion.
What happened? Huh? What? In dynamics, what it is happening? To whom we should call static and to whom we should call dynamics? In dynamics, body is in motion, simple. And in static, body is at rest. In both cases, we are studying forces and their effect on the body. Is it correct? So this one is the syllabus. From the second section, this chapter is most important and will have more weightage. Other chapters are small and having less weightage. So if this chapter will cover, almost we will reach to 80 to 85% coverage of syllabus. So that also you should keep in mind. The statics and dynamics. So quickly, if I will tell here what is difference. If you'll see the syllabus, so in statics and in dynamics, one difference already we have seen. So in short, I will write here. Maybe suppose I will write here statics. Just I'm telling, don't write it. This you have studied. Statics means body is at rest. Only I will write rest. And in motion, this thing is common now, well known. We should know this. Apart from this, once we are going to solve the problems, no. So in statics, whatever given things are there, given easily we can say what it is given. Easily, I am saying it is not actually difference, but once you will study dynamics, you will come to know that easily. Means once we are going to solve the problems, you will come to know that what it is given in the problem. Here it is very difficult. So understand, because body is in motion. Whether it is given initial velocity, whether it is given final velocity, and so on. Whether displacement is given, total displacement is given, half displacement is given. So this one is very difficult in this case, kinematics, or we can say in general dynamics. So once we are going to study, you will come to know that it is very difficult to understand. So analysis of problem, we can say, to analyze the problem, what it is given, it is difficult in case of dynamics, but it is not the case in case of dynamics, or in case of statics, it is not the case. One more thing I forgotten. So syllabus for IC2 I told, no, already I have told. So
Yes,
there may
sir.
be certain questions will come up. For example, we have not taken one question, something like this. Maybe a standard diagram. Suppose equilateral triangle, maybe something. This all sides are equal. Where is the center of this? At what distance it is? Suppose a equilateral triangle. So you should not feel that this question came out of syllabus. If equilateral triangle of side A, and suppose we will draw median for it. Median मराठीमध्ये मध्यगा असं म्हणतो बघा आपण. जर अशा मध्यगा जोडल्या त्याच्या इथून अशी गेली एक इकडून एक अशी गेली, समथिंग लाईक दिस. नॉट एक्झॅक्टली बट समथिंग लाईक म्हणजे इथून एक. सो व्हॉट दिस पॉइंट इज कॉल्ड centroid. So you should be able to find these distances. I kept one MCQ on this. So just I have given clue. So otherwise you will again quarrel with me at the end. Why this you have not told? But so again, especially Sakshi will quarrel. That's why I told this. So something like this. I have given clue. So don't expect as it is the things. You should be able to apply the trigonometry, whatever, etc., and to find the distance, what it is asked, etc. So one question I kept like this, and remaining you will come to know that during IS. So what I want to tell here, don't expect all the things here. You should search in book something. Maybe you should Google it. You should refer the assignment booklet, etc. Don't expect everything should be covered, because a specialty of subject is what, once one value is going to change, one value will change, everything will change. It is as simple as this. Coming back to our dynamics, I told already difference between static and dynamics already I have told. Now coming back to here, a simple thing. Here we are going to study mechanics in which body will be in motion. Means problem something like, suppose I have given example at the initially. If you have thrown suppose stone in the air, so if you will consider that stone, no, that body is in motion, something like this, projectile motion. It is called here it is projectile motion. So have you heard these terms? I'm going forward or backward? Yes. Projectile motion means at what time it will reach at maximum height, what will be its traveling, etc. So it is called as projectile motion here. So here first thing you should keep in mind, body will be in motion. Is it the case in our statics? Whether it was a case in case of our स्टॅटिक्स मध्ये असा कुठला प्रॉब्लेम होता का की बॉडी मोशन मध्ये होते? देयर वॉज नो. सो हियर देयर विल बी द केस. सो बेसिक्स you can read on the slide. Motion is one of the most common phenomena we come across in daily lives. So it is simple. For example, a moving car, a kid running on the road, or a fly moving in the air are all said to be in motion. Okay. So in general terms, a body is said to be in motion if it changes its position. Very basic. When we are going to say body is in motion, when we have to say body is in motion, if it changes its position with respect to what? With respect to
point and time.
Reference point and time. If at all it is going to change its position, then we can say body is in motion. So then in dynamics, obviously body will going to change its position with respect to point and the time. Okay, are you with me?
Yes, sir.
Then depending upon the path taken by the particle, the motion can be different types, like projectile, rectilinear, rotational, etc. The different types of motions are there. Not only this, so you might be heard something like maybe suppose curvilinear motion or rotational motion. Have you heard this rotational motion? Here it is there.
Yes, sir.
Yes, sir.
Okay. Projectile motion, rectilinear motion. What is the difference between linear and rectilinear motion? काय फरक असू शकतो याच्यामध्ये?
Motion of an object
Ah.
vertically upward, projected vertically upward in a projectile motion.
Very good. You have told projectile motion. तुम्हाला ऐकू येत नाही का? One answer came here. What is projectile motion? Means if suppose not only vertical, somebody has given answer something like it will throw in vertical direction. Verticalच नाही. Suppose तुम्ही उभा राहिलेला आहात, suppose on ground, and you have thrown a ball in air. That will be a projectile motion. काय म्हणता साक्षी? that I'm telling. Not only vertical. Verticalच नाही. Who has given answer this? Vertical. कोण सांगत होतं
Sir, I,
okay
Rutuja.
okay so not only vertical, you can throw in horizontal direction also, a little taking inclination with horizontal. Rectilinear, what will be the rectilinear motion? Rectilinear and linear, is there any difference? काय असू शकतो फरक? Apply the mind. Linear and rectilinear. Forget about rectilinear. What about linear? What is linear? Straight line. बरोबर आहे. Straight line means motion will be there only in straight line. Rectilinear काय म्हणता येईल? Rectilinear means what? Linear, whatever you have told, it is correct. Initial point. Sorry, I can't write. Initial point, and suppose here somewhere final point B, I will say A and B. So this is a straight line motion. But suppose object is starting at this point, suppose 1. It goes to suppose point number 2. Again, it is maybe something like this, straight. Again, it goes to point number 3. Maybe here something like 3. Then here 4, 5, something. आता ही मोशन कसली लिनियरच राहिली का कशी बदलली वगैरे अशी काय झालं तर something like this, but it is changing its path, but motion is linear only. आता परत थोडंसं डीप मध्ये जातोय आपण. Just you can remember this. Linear means end point and we can say initial point will be at one line, एका line वर असतील, but it is not the case with rectilinear motion. Something like this. आला का फरक लक्षात? रेक्टिलिनियर आणि लिनियर मध्ये काय असतं? Then rotational motion. Rotational motion. An example of rotational motion. Okay, there may be two terms then, rotational and curvilinear. Curvilinear हा शब्द ऐकलाय का तुम्ही? ते काय असते सांगा बरं बघू. What is curvilinear then? Many more are there. Our rotational, curvilinear, maybe oscillatory. I have not included all. Again, maybe, maybe angular again.
Circle.
Again, in other etc. It means there are something more, not only these many. Again, anything more? Oscillatory.
Sir, object curved in
okay.
One path.
Object will take curved path means curvilinear motion. You want to say? Okay. Again.
yes.
Again. Or curvature path. Oscillatory. Okay. Then what is vibratory then? I click the term here. What is vibratory? Suppose there is string fit to these 2 points. You will give jerk here. Rich motion कशी होती है अशी? Maybe something like this. Something like this. अशी असते ना? Vibratory, oscillatory, angular, curvilinear, rotational, periodic motion. So just it is a we can say, don't worry if you are not knowing exactly. This is not, it is basic only, introduction. We should know these things. That's all, nothing else. So that it was there, projectile motion. So here we should know when we have to say bodies in motion, when we have to show bodies in motion. Further, what are the different types of motion? दोनच पॉइंट बघितले आतापर्यंत आपण. कधी म्हणायचं बॉडी मोशन मध्ये आहे? When we have to say bodies in motion. Yes, if body changes its position, most important word. This one is most important word. If it will change its position with respect to reference point and time, then we have reference point म्हणजेच place. म्हणजे तुम्ही आता कॉलेज मध्ये आहात, हा रेफरन्स आहे तुम्हाला फॉर युअर पेरेंट्स, वी कॅन से something like this, reference point and time. And motion, different types of motion we have seen. Then distance and displacement. Not to discuss more on this, everybody knows distance and displacement. What is basic difference between this? displacement is vector. What is the unit of displacement and distance then? It may be unit of distance or length, we can say length. Simple. So basic difference, distance is defined as the total path of length converted or not converted, covered, sorry, covered during a journey, while displacement is defined as the shortest distance between final and initial point that you have studied. So this diagram only I have kept for your introduction, so you can see what is distance and what is displacement. In your own word also you can write that. Okay. Next, yes, speed and velocity, same. Next one is speed and velocity. The terms are used to describe the rate of change of position. Speed is rate change of distance, while velocity is a rate change of displacement. Okay, comparing from above, distance can be a negative. Sorry, distance can never be a negative. So the speed is never negative, while velocity both positive or negative. In mathematical terms, we know the formula: speed is equal to distance traveled divided by time taken. So if we indicate speed, let it be in this: speed is equal to distance traveled divided by time taken. So you can write speed and velocity is equal to final position minus initial position. Means again it is displacement upon time. We can say velocity. Okay. So 1 mark MCQ question may be asked on this. Always it is asked 1 mark on basics. Maybe 3 quantities are given scalar, 4th one is given vector, something like this. Maybe the formula, maybe the example of we have seen, whatever, maybe any type of example. So I have given certain, you can prepare. Suppose example of fan we will take. Fan, which type of motion fan is having?
Rotational motion.
Rotational motion.
If you will take, okay, rotational, can we say not rotational, curvilinear, something like this?
Yes, sir. Curvilinear.
Huh?
Yes,
Curvilinear?
yes.
पण
सर रोटेशनल पण वाटतंय.
रोटेशनल पण वाटतंय. मग कर्व्हिलिनियरचं काय?
कर्व्हिलिनियर कर्व्ड
What
मध्ये
is the motion
असताना
of Earth? In which category it will fall? Earthला 2 मोशन असतात ना, रोटेशनल आणि दुसरी स्वतःभोवती फिरते त्याला काय म्हणणार? तुम्ही अभ्यास करा आता त्याचा, मला सांगा. You can go for study. Okay, revolutory we can say. It is revolving around its own axis, and it is around whom? Sun or moon? I don't know. Huh? Sure? Around sun.
Sun.
And what about moon? Okay. Weak in which category? Geography? I don't. Let us go next. We are not interested in motion of Earth. पृथ्वी कशी काय फिरणार? आपण पृथ्वीवरती आहोत. Don't worry. Rectilinear motion, coming back. Application of mind is required in engineering. I am saying, don't mug up the thing. Mug up you are knowing. Mug up means पाठ करणे. पाठ करायचं नाही काय. You should not mug up the thing. काही सुद्धा पाठ करायचं नाही. समजून घ्यायचं काय आहे. And don't expect being, I don't know, up to 12th, your 12th class, you might be expecting as it is from the notebook. असं होतं का? एखादं suppose one problem is not taught by the teacher and it came into exam. मग टीचरच्या नावाचा तुम्ही जे जे कार करत असताल कदाचित. It should not. 3 marks are very less, no, in that case. It should not happen. What is my conclusion here? You should not expect everything here. You should try on your own. Which book you are using for our subject? Anyone? What is the name of author? Which book you are using for our subject?
Bhavikatti.
What is the name of book?
Engineering Mechanics.
Okay, engineering mechanics by Bhavik Katti. So you should remember that at least for our subject, which book you are using for mathematics? Okay, GV Kumbhoshkar. Something like this. I don't know, but you should use. Try to use this. Don't depend everything here. That I want to tell here. Rectilinear motion. Next. Are you writing or are you just taking screenshot? Who is attending the lecture? I'm asking to online student. Are you writing?
Yes, sir.
Okay. Today, okay, rectilinear motion. Now coming back to a rectilinear motion is a motion of a particle. Is a motion of particle or object along a straight line. मी मगाशी सांगितल्याप्रमाणे. मग rectilinear आणि linear मध्ये काय फरक आहे? It will join its starting point and end point, we can say final point. There will be straight line in case of linear motion, but it is not the case in case of rectilinear motion. येते का लक्षात बघा बरं काय म्हणतोय मी? What I want to say, are you getting? असं straight line असतात वेगवेगळ्या. Or we can say in other word, in a rectilinear motion, it is a combination of number of linear motion. असं म्हणूया आपण. In short. Examples, the use of elevators in public places. Okay, gravitational force, many more examples will be there, forget about it. There may be a certain examples for rectilinear. Types of rectilinear motion, a little ahead. तुमचं काय चाललंय बघा, लिहिताय का तुम्ही? ठीक. Types of rectilinear motion. So number 1, uniform rectilinear motion, to whom we should call it as a uniform rectilinear motion when an object travels at constant speed with zero acceleration. Meaning of uniform is that only whenever there is zero acceleration. What is acceleration? Rate of change of velocity. Okay, it is known as it is known as uniform acceleration is zero, means it is constant simply. Then uniformly accelerated rectilinear motion, when an object travels with constant acceleration, it is known as uniformly accelerated rectilinear motion. And rectilinear movement with non-uniform. What is this accelerated motion and this non-uniform acceleration? याच्यामध्ये काय फरक आहे माहिती आहे? Uniformly accelerated, it is accelerated means what? Speed is going to increase. Constant acceleration. कशामध्ये? Uniformly accelerated मध्ये का? What about this? Non-uniform, we can say it is when, or we can say here it is written, इथे दिसतंय का? Irregular speed म्हटलंय बघा. Irregular speed and acceleration is known as rectilinear movement. Something. Non-uniform साठी म्हणतो मी, non-uniform साठी. Irregular speed. इथं regular राहतं. Something like this. हे थोडंसं कन्फ्युजिंग आहे बरं का डायनामिक्स. वी फील इट इज सिम्पल. पाहिल्यानंतर वाटतंय म्हणजे किती सोपं आहे. वन्स यू विल कम टू नो दॅट इट लिटल डिफिकल्ट टू अंडरस्टँड व्हॉट इट इज गिवन. ड्रॉबॅक ऑफ डायनामिक्स इज व्हॉट, मी पहिल्याच स्लाइड मध्ये लिहिलं होतं बघा की काय दिलं हेच समजत नाही. इट वॉज नॉट द केस विथ अवर स्टॅटिक्स. There were certain forces, certain distances, we can apply trigonometry, etc. Here it is a little difficult, and if you will commit the mistake while what it is given, further things there is no use. So that's all. Forget about it. This one is very basic. It will not going to help us further. Just as a part of syllabus, I have kept here rectilinear motion. Okay, next one is relative. I think in one of the lecture we have discussed about this. What is relative velocity or relative motion? कोण सांगताय मग हे? Relative means difference. I have told you might be knowing this. Relative means difference in motion. Example एक दिलं होतं बघा मी, आठवतंय का? बसचं एक्झाम्पल दिलं होतं बघा. इफ देर आर टू बसेस ट्रॅव्हलिंग टुगेदरली, सपोज दे आर गोइंग टू पास इच अदर, okay, for certain time speed of both the buses will be same for certain time. At that time what we feel, काय वाटतं आपल्याला? We are at stationary, आपण जागेलाच थांबलोय असं वाटतं. Okay, on the other hand, if example of trees, we will take trees, something like this. We feel that trees are traveling, we are at stationary, something like this, because whatever trees etc buildings are there, these are stationary, but we are in motion. So it may be something like relative motion. Okay, here number of examples will be there. The motion of the object with respect to other moving or stationary object is called as, आता इथं difference word वापरला नाही बघा intentionally, but it is given with respect to other म्हटलंय बघा. That word is used here, so you can see, or in simple words you can say relative velocity or relative motion means what? Difference in motion. It is simply a difference in motion. Okay, relative motion is a calculation of the motion of an object regard to some other moving or stationary object. Okay, for example, a person sitting in an airplane, okay, is at zero velocity relative to airplane, but is moving at the same velocity as the airplane with respect to the ground. काय म्हटलंय बघा बरं, कोण सांगतोय? I don't know what it want to tell. काय म्हणायचं यांना? Who will explain this example? Ha. Relative motion or relative velocity. What here this example want to tell? A person sitting in aeroplane. Aeroplane च्या आणि त्या पर्सन ची velocity सेम असेल का वेगळे असेल?
Same.
No. Only we will consider. No. Only we will consider that person and aeroplane. या दोघांच्या velocity काय फरक असेल का? No. Is there any relative velocity between them? त्यांच्यामध्ये काय डिफरन्स आहे का नाही म्हटलंय बघा. That's why it is at zero relative velocity. On the other hand, with respect to ground, there may be the difference. That's why it is called as a relative velocity. So relative velocity means difference, that you can say only. It is nothing but difference, nothing else. Okay.
Sir, previous slide.
What?
Previous slide.
Okay. Are you observing now?
Slide.
This one, no? Relative velocity, no?
Before
Or before this? Which you want?
Yes, sir, before this.
Before this. Okay, this. This one?
Yes, sir.
Okay. Take this then. What you want?
Done, sir.
Okay. This, whether it is done with this?
Yes, sir.
Okay. Next one. Equations of motion. How many equations of motions are there? Now our actual syllabus is going to start from here. Now you should give attention. So whatever it was there, it was a theoretical part, but now actual part will start from here. How many equations of motions are there? I think we have discussed in chapter
Three.
number 1. Maybe
3.
in chapter number, I think 1 something in introduction we have seen. Which are they? How many are there and which are they? 3 equations of motions are there. Okay. So if we'll see, first one is P is equal to U plus AT. First equation. Second equation is S is equal to UT plus 1/2 AT square or 0.5 AT square. Third equation is P square is equal to U square plus 2AS. So what are these terminologies? लिहून घ्या सगळेजण, तुम्ही पण लिहून घ्या. You also write in your notebook. लिहून घ्या, लिहून. Write in your notebook equations of motion. And let me know the terms in this. What is V? Maybe what is V? Then what is U? Then what is A? Then what is T? Okay, anything else? Yes. What is yes? Displacement. What is A?
Acceleration.
What is, and then what is G? Gravity. What is its value?
9.8.
9.8.
There are two things, no, you might be knowing. If motion is in upward direction and motion is downward direction, when to take positive and when to take negative, are you knowing this? When to take it positive and when to take it negative, meter per second square, no? Or you are not taken sometimes negative? Sure. No. How center gravitational force is acting towards the ground, or if it is along the gravitational force positive, म्हणजे downward positive, बरोबर आहे. Downward positive and upward will be negative. So this also we should know. So if anyhow you will make mistake here also, it will go wrong. Okay. So once again I will repeat the terms what they are here. कुठल्या टर्म आहेत परत एकदा सांगतो बघा. V means what? V final velocity in meter per second. What is U? Initial velocity in meter per second. A acceleration due to gravity. T is time. S is displacement, maybe in meter, centimeter, mm, whatever it may be. In gravitational, this we should know. If you see now equations of motion, V is equal to U plus AT, S is equal to UT plus 1 of AT square, and this V square is equal to U square plus 2AS. What we will get from equation number 1?
Final velocity.
Okay, final velocity. One answer came as final velocity. Okay. Okay, final velocity. Okay. What we will get from the equation number 2?
Displacement.
Okay, displacement. And what we will get from equation number 3?
Final velocity.
Again, final velocity? No. I'm listening to online students. Online. Those who are online, I'm writing their answer. Again, here final velocity. Is it correct? So what is the difference between this first and second? Sorry, first and third. इथं पण आहे हेच आणि इथं पण हेच आहे. हे पण डिस्कशन झालंय आपलं. What is, why it is necessary of equation number 1 and 3? If at all we will get final velocity in both cases. कुणाला आठवते सांगा. Those who are attending from home. Quick, fast. Who will tell what is the difference between equation number 1 and equation number 3? Are you aware about these equations? माहित करायचं ना इक्वेशन तुम्हाला हे? Are you knowing?
Yes, sir.
Yes, sir.
Okay. Then tell me what is the difference between equation number 1 and 3? Or both are same? आपलं झालेलं आहे सगळं. रोल नंबर 4 सांगा बरं. रोल नंबर 4.
Yes, sir.
सांगा की. ऍटलिस्ट इक्वेशन वेगळे आहेत असं तरी सांगा. डू यू वॉन्ट टू टेल समथिंग? साक्षी कदम पाटील. 11.
Yes, sir.
What is the difference between equation number 1 and 3? Or you are not knowing, you can tell not knowing. Or forgotten. Now not knowing answer will not be applicable because already we have discussed this. Already discussed mechanics. Why? In both the case, if at all it is giving final velocity, then why two equations are required? Shiv Kumar Bhosle, roll number 13. What is difference?
Yes, sir.
Difference. Equation number 1 and 3. If at all both are giving same entity, final velocity, then what is the difference between them? Is there any difference? Omkar Mani, 39. Omkar Riddhi, 46. Pratik Sutar, 61.
Yes, sir.
Do you know what is the change or difference between equation number 1 and 3?
पहिलं सर velocity साठी आणि दुसरं displacement साठी.
दुसरं पहिलं आणि तिसरं म्हटलं मी. First and third, not first and second. First and third. What you will we are getting from equation number 1 and from what we are getting equation number?
सर पहिलं with respect to time and दुसरं with respect to displacement.
Okay, good. At least you have tried. Good thing. Actually, that is not the answer you have told with respect to time and etc. So in first equation, I am remembering we have discussed this also. We can get velocity at any instant of time. Velocity. I will say velocity. I cannot say now final velocity. Velocity at any instant of time. कशावरून म्हणतोय मी असं? Because there is any instant of time. Because there is time in first equation, and here what is happening in here? Third equation.
Velocity of body.
Okay, here why we are saying now velocity of body? Is it the only velocity or it is final velocity? It is
Final velocity of body.
It is final velocity. Directly we can say. See, this equation will get final velocity. Okay. So these things are already you have studied in your 12th, if I am not wrong.
Yes, sir. Yes.
11th. Very good. Here I will ask one question then. How this first equation came? कसं काय तयार झालं कोण सांगू शकेल का? Graph. Forget about graph चा काय संबंध? No graph. Will you tell how this first equation came? Graph. I don't know. Okay, other. कशावरून आला असेल फर्स्ट इक्वेशन अप्लाय द माइंड बेसिक वी आर नॉट लर्निंग हियर रॉकेट सायन्स बेसिक कसं आलं असेल कोण सांगते बघूया फर्स्ट इक्वेशन लेट अस सी फर्स्ट इक्वेशन मग कसं आलं हे इक्वेशन v is equal to u plus at
That gives the difference between velocity and time. Relation between velocity and time.
okay how this equation came नाही डेरिव्हेशन नाही होईल डेरिव्हेशन वगैरे काही नाही मला सांगा सिंपल व्हॉट इज डेफिनेशन ऑफ एक्सेलरेशन
Rate of change of velocity. Rate of change of velocity.
एक्सेलरेशन ची डेफिनेशन काय आहे चेंज इन वेलोसिटी चेंज इन वेलोसिटी डिवाइडेड बाय आता आपल्या दोन वेलोसिटी कुठले आहेत आपल्याकडे आणि एक्सेलरेशनला आपण काय म्हटलंय ए इनिशियल आणि फायनल, मग चेंज कसा करणार? व्ही मायनस ई, व्ही मायनस यू डिवायडेड बाय टी. आता ह्याचं सिम्प्लिफिकेशन करून हे इक्वेशन येते का बघा. इट इज ॲज सिम्पल ॲज दिस. येते का? व्ही इज इक्वल टू
Yes, sir.
यू प्लस एटी, यू प्लस एटी. इक्वेशन नंबर 1 आलं. एक्सलरेशनच्या डेफिनेशन वरूनच आलंय पहिलं इक्वेशन, नथिंग एल्स. त्याच्यामध्ये काय ग्राफ वगैरे तुम्ही जे सांगताय मला काय माहित नव्हतं. इट मे बी, आय डोंट नो, इट मे बी समथिंग लाईक दिस. हे असं आलं सिम्पल. कसं आलं इक्वेशन? म्हणजे हे नुसतं पाठ केलंय तुम्ही आतापर्यंत. व्ही इज इक्वल टू यू प्लस एटी, तोंड पाठ आहे सगळ्यांचं. एव्हरीबडी इज नोईंग दिस. इफ आय विल से, म्हणजे झोपेतून जरी कुणाला उठवलं आणि सांगा इक्वेशन म्हणलं तर तुम्ही लगेच सांगू शकताय. But from where it comes, that also we should know. Simple, huh? It is very simple. Let us say other speed displacement. Okay. आपण स्पीड कसं देतो? स्पीड, व्हॉट इज युनिट ऑफ स्पीड? मीटर पर सेकंड. मीटर पर सेकंड. मग इथं काय आहे आपलं? डिस्प्लेसमेंट. But there are two speeds now. Okay. If you'll see now, we will try. Suppose distance is equal to, काय फॉर्म्युला होईल मग? Distance is equal to S is equal to VT. हा फॉर्म्युला लक्षात ठेवा बरं का. हा फॉर्म्युला लक्षात ठेवा. तुम्हाला ऍप्टिट्यूड साठी तुम्ही कुठल्याही ब्रँच असू दे, तुम्हाला हा फॉर्म्युला लागणारच आहे. S is equal to VT. S is for displacement, V for velocity in t is time. But whether we are having only one velocity here, आपल्याकडे दोन आहेत का आता? सॉरी, एक आहेत का दोन आहेत व्हेलॉसिटी? दोन आहेत. म्हणून काय करावं लागतं आपल्याला? ऍव्हरेज व्हेलॉसिटी म्हणावं लागेल. हिअर वी हॅव टू से ऍव्हरेज व्हेलॉसिटी इनटू टाइम. बघूया आपण हे इक्वेशन येते का. डिस्टन्स कव्हर्ड म्हणतो मी, और डिस्टन्स ट्रॅव्हल्ड, समथिंग लाईक दिस. डिस्टन्स ट्रॅव्हल्ड इज इक्वल टू ऍव्हरेज व्हेलॉसिटी. हा, एस इज इक्वल टू डिस्प्लेसमेंट. येस आपण डिस्प्लेसमेंट म्हणणार आहे किंवा डिस्टन्स ट्रॅव्हल्ड. ऍव्हरेज व्हेलॉसिटी कशी करणार तुम्ही? व्ही इंटू, सॉरी, व्ही प्लस यू डिवाइड बाय 2 इंटू टी. बघा बरं आता ह्याला काय करून ते एस येता येईल का आपल्याला? Can we do something here so that we will get yes? Suppose we will put directly value of v. Equation number 1 मध्ये v ची व्हॅल्यू आहे बघा. बघा बरं काय होतं ठेवून. Then what will happen? S is equal to v ची व्हॅल्यू काय आली सांगा बरं? u plus 80 plus परत u येणार काय? प्लस u डिवाइड बाय 2 इंटू टी. बघा बरं जरा सिम्प्लिफाय करून येतंय का ते? 2s, or if I will simplify here, so what it will be? 80 plus 2u divided by 2 into t. नाही काय? पण हा ब्रॅकेट आहे बरं का आपला. बघा बरं, टी ने जर मल्टिप्लाय केलं तर काय येईल? पुढे लिहू काय इकडं? मग काय येणार? 80 स्क्वेअर प्लस 2u डिवाइड बाय 2 येते काय? इकडे यस आहे, बरोबर आहे ना? ut यस इक्वल टू यस. झालं की मग इक्वेशनच आलं की डायरेक्ट. आता ह्या 2 ने जर डिवाइड केलं तर इथलं कॅन्सल होणार हे, आणि इकडे 1/2 80 स्क्वेअर राहत आहे. आलं की इक्वेशन. म्हणजे काय झालं? एस इज इक्वल टू ut प्लस हाफ म्हणा किंवा 0.5 म्हणा, 1/2 80 स्क्वेअर झालं. आलं इक्वेशन आपलं हे. फर्दर आता हेच, आता आपण इथं काय केलं होतं? व्ही ची व्हॅल्यू ठेवली होती, व्ही ची. आता टी ची ठेवून बघा इक्वेशन नंबर 1 वरून. लेट अस सी वेदर इट इज कमिंग फॉर, जरा असं करतो हे लक्षात येणार नाही. फॉर्म 1, फॉर्म 1 here now, third. Just we are trying. whether we are getting the equations or not. Let us say. What is our distance is equal to? Distance is equal to average velocity into time. Okay. So from equation number 1, what will the formula for time? Time's formula काय येईल बघा बरं जरा. So S is equal to average V plus U divided by 2 into time now. Put the value of time from equation 1. Time value to what it will be? V minus U upon A. V minus U upon A. बघा सोपं आहे मग मॅथमॅटिक्स A प्लस बी आणि A मायनस बी चं काय असते हे इथं बघा A स्क्वेअर मायनस बी स्क्वेअर व्हेरी सिम्पल आणि हे 2A आहे at the denominator it will come to left hand side it will become 2as. 2as is equal to लक्षात येते का नाही बघा बरं it will become 2as is equal to v square minus u square झालं simple. So our equation will be v square equal to v square is equal to u square plus 2as. Is it the case? तुम्ही कसं काढत होता 12वीला हे ग्राफिकल डेरिवेशन कसं काय काढता ग्राफने कसं डेरिवेशन काढता म्हणजे हाऊ यू आर गोइंग टू यूज ग्राफ फाइल डेरिवेशन I'm not sure. Please note down this. At least you should know equations of motion. First, you should know equations of motion. Whatever I have written, it is over and above. We can say. Is how you should know from where these equations came. That you should know. Okay, are you with me? Those who are online.
Yes, sir.
Have you understood how these equations came?
Yes, sir.
Yes,
Before that-
sir.
I will check. Okay, have you understood? So first thing, what the question I have asked? How many equations of motions are there? 3.
3.
So whatever we have written, v is equal to u plus at, s is equal to ut plus 1/2 at square, v square is equal to u square plus 2as. Okay. Further, what is that? What is the difference between equation number 1 and 3 that we have discussed? What is the difference 1 and 3? First equation will give final velocity at any instant of time, and third equation will automatically it will give final velocity. So if at all, if there is offline exam and if it is asked to derive these equations, is it difficult to derive? From where we have derived this? Definition of acceleration. Simple. How we have derived these 3 equations? From definition of acceleration. I have written here. Are you getting? Where it is? Here, acceleration. So what is acceleration? You know better. What is acceleration? All the 3 equations we can derive from, definition of acceleration. Acceleration is equal to change in velocity divided by time. So acceleration, because here there are 2 velocities, v minus u divided by t. So a is equal to v minus u divided by t, v is equal to u plus at. This simple equation you will get. That is the first equation of motion. In this equation, only we have to put value of further taking the formula for distance. Distance is equal to average velocity. हा फॉर्म्युला कोणाला माहिती आहे कसं येतो? थोडंसं जर हा कसा येतो आपण म्हणतो बघा 2 व्हीलर माझी 60 किलोमीटर पर स्पीड जर बघितलं तर काय युनिट असतो 60 च्या स्पीड न गाडी गेली म्हणलं तर 60 चं युनिट काय असतं 60 किलोमीटर असं असतंय का पर आवर वगैरे असते पर आवर म्हणजे हे वरती आलं काय डिस्टन्स, म्हणजे हे काय आहे आपलं स्पीड आहे. आपण ह्याला स्पीड म्हणतोय ना, की आपण आपली गाडी 60 किलोमीटर पळवली म्हणजे ते ऍक्च्युअली किलोमीटर पर आवर असते बरं का, म्हणजे स्पीड आलं आपलं. मग स्पीडचं युनिट काय येतं त्यासाठी मी सांगतो. हे काय असणार, किलोमीटर म्हणजे डिस्टन्स, मीटर सपोज, मीटर पर सेकंड समथिंग लाईक दिस. आता आपण हे डिस्टन्स घेतोय, हे डिस्टन्स मी लिहिले डिस्टन्स ट्रॅव्हल्ड, मग हा टाइम गेला इकडं, म्हणून स्पीड इंटू टाइम इट विल गिव्ह डिस्टन्स. असं बऱ्याच जणांना इथं पण कन्फ्युज होतं की काय आहे हे तुम्हाला ऍप्टिट्यूड साठी फार महत्वाचं आहे. तुमची ब्रँच महत्वाची नाही, तुम्ही कुठल्याही ब्रँच असू द्या. हा फॉर्म्युला जो आहे ना, मी इथे लिहिलाय ना, ह्याला स्टार मार्क करतो. त्याच्यावर ते बरेचसे प्रॉब्लेम सुटणार आहेत ऍप्टिट्यूड मध्ये. तुम्हाला रेल्वेचे वगैरे प्रॉब्लेम असतात ऍप्टिट्यूड साठी. माहितात का ऍप्टिट्यूड ऐकलंय का हा शब्द?
Yes, sir.
इन दॅट ऍप्टिट्यूड मे बी इन युअर, आय थिंक तुम्ही बुद्धिमत्ता चाचणी वगैरे काहीतरी म्हटलं असतं. इन दॅट इट इज मोस्ट इम्पॉर्टंट. एस इज इक्वल टू व्हीटी हा फॉर्म्युला लक्षात ठेवा. तुमचे नंबर ऑफ प्रॉब्लेम्स यू विल सॉल्व. Yes, for what S stands for here? S is displacement, V is velocity, T is time. तर एवढा एकच फॉर्म्युला लक्षात ठेवा, याच्यावरती बरेचसे एक्झाम्पल सुटते. ओके, these are the basic things which I want to discuss today. आणि जाता जाता आपण बघूया डिफरन्स बिटवीन कायनेटिक्स अँड कायनेमॅटिक्स. Shall we see today or shall we see it tomorrow? Okay, while going only we will see what is this, just for our information. We are you going to take this we will see. Already we have studied this kinetics and kinematics. आपण ऑलरेडी पाहिलेलं आहे. आठवतंय का कायनेटिक्स म्हणजे काय, कायनेमॅटिक्स म्हणजे काय? आपल्या चॅप्टरचं नाव काय आता? व्हॉट इज द नेम ऑफ आवर चॅप्टर नाव? कायनेमॅटिक्स. सो यू कॅन सी दॅट रो. आपण इथं काय करणार आहोत? वी आर गोइंग टू स्टडी द पोझिशन, ऍक्सेलरेशन, स्पीड अँड ऑब्जेक्ट. ऑन द अदर हँड आपल्याला पुढे पण जाऊन शिकायचं आहे. कायनेटिक्स मीन्स व्हॉट, दॅट ऑल्सो वी आर गोइंग टू स्टडी. देअर वी आर गोइंग टू स्टडी कॉज फॉर द मोशन. काय असतं मोशनचं कॉज कशामुळे असतंय? फोर्स. मीन्स इन कायनेटिक्स वी आर गोइंग टू स्टडी फोर्स. आपल्याला इथं कायच करायचं नाही, आपण एक फक्त म्हणणार स्टोन इज थ्रोन बाय द मॅन. एका माणसानं दगड फेकला, किती फोर्सने फेकला वगैरे काय देणं घेणं नाही. समथिंग लाईक दिस. इथं आहे बघा एक पॉईंट. Force is not going to consider here. Also mass we are not going to consider in kinematics. And it is applied to study movement. हे जाऊन काय हे फार मोठा आहे, कळणार नाही काय. And involves the mathematical expressions. इथं काय नसतात ते आपण बघू. म्हणजे इथं आताच आपण पाहिले मॅथमॅटिकल एक्सप्रेशन्स कसे असतात. ओके, आफ्टर दिस आय थिंक फॉर problems are there but we will solve it tomorrow. With this we will stop for today. Okay, meanwhile I will take just attendance. Those तुमचं कसं असतं अटेंडन्स? तुम्ही लॉग इन करताय का? नाही केलं का? I will take then from sir. Now they 1 2 3 3 roll number 3 4 5 6 7 8 9 10. roll number 10. इथं कोण आहे का 10? इथलं कोण असेल तर सांगा. रोल नंबर 10 absent. 12 absent. 21 25 25 absent. 27 absent. 32 33 41 कोण आहे का इथं? 47 ओके. 48 53 okay. Thank you those who joined. We will see remaining part tomorrow.